All right, welcome to Unit 1, Lesson 7. We are going to be solving quadratic equations. We've been factoring them already, so we're going to continue factoring, but now we're just going to add one small thing at the end, and that's the solving part. So if you're not really comfortable with factoring yet, I would continue to factor until you are, because that's critical. So let's go ahead here. First of all, zero product rule. This is kind of important, kind of not. I'm not really going to pay too much attention to that. But what I want you to notice is this is critical. All quadratic equations must be in this form before you find the solution. But more importantly, they must be set equal to 0. That's the killer thing here. So a lot of quadratics may not have all three terms, and that's fine. But it must be set equal to 0 before you can solve. And in order to solve quadratic equations, there's really three ways we can do this. We can factor. Okay, that's what we're going to focus on today. We can use the quadratic formula, which is what is going to be closer to the end of this lesson. And then there's completing the square, which I think will be the next lesson after this, or the one after that. But for right now, factoring and quadratic formula is where we're going to be. All right, method 1, solving a quadratic equation by factoring. All right, so I take a look at my example here, and I'm going to write some steps down as I go. And the very first thing I want to do is I want to set my equation equal to 0. All right? So what I'm going to do is I'm just going to add 12 to both sides. X squared minus 7x plus 12 equals 0. Now, step 2. I have my quadratic equation. It's set equal to 0. Now I'm going to factor it. Okay, I'm going to factor it. Lucky for me, this is a product sum situation. Two numbers that multiply to 12 that add to negative 7. Okay? Here's my factoring. I'm using x's. Negative 4 and negative 3. They multiply to positive 12 and they add to negative 7. So we're good. But let's not forget, it still equals 0. All right? Now on to the final step. After I factor, I now solve. And how do I solve? I set each parenthesis equal to 0. All right? So my last step, I say x minus 4 equals 0. And I have x minus 3, I set that equal to 0. So when I say set each parenthesis equal to 0, I'm referring to this parenthesis. I'm setting that equal to 0. And I'm taking this parenthesis and setting them equal to 0. Now, if we can go back for a second, when I said this isn't so important to explain, I'm going to take a moment and actually explain it now that we're in the middle of doing a problem. If I have this, okay, if you have a product and it's equal to 0, one of these has to be 0. All right? In other words, if A is 0, 0 times B equals 0, right? Or my B can equal 0. So I can say A times 0, that equals 0. So one of them, okay, one of them should be 0, because 0 times anything is 0. That's why when we set this up here, either this one, this could be my A, either that equals 0, or my second parenthesis should equal 0. That's the only way I can get a product equal to 0. Is that really important to know? You don't need to know that to solve this, as long as you follow these steps. But it gives you a better sense mathematically of what's going on. So that's not critical to know as long as you do this step right here. So let's actually solve these. I'm going to add 4 to both sides. So x equals 4. That's one of my answers. And if I add 3 to both sides, x equals 3. That's another answer. So I'm going to take a look at my original equation. I want to point a couple things out. These two answers work here. If I throw 4 into both of those x's, it should equal negative 12. I just solve for x. Same thing, if I throw a 3 into either one of those, if I throw this 3 into either one of those, or actually if I throw a 3 into both of those, it should also equal negative 12. But here's something that I also want to point out, and as we move forward, this is something that we can notice. I have 2 answers here. There are 2 answers. The degree of your quadratic or your polynomial, that's the biggest exponent, is 2. That will always tell you how many answers you should have. I should have 2 answers. All right, so that's just something that we can reference. That should match. All right, let's do a few problems here. We won't do all of these, but if you want to go ahead and do some of these, go ahead and you can check your work based on what I do right now. This first one, I'm going to set it equal to 0. Subtract 6x from both sides. 2x squared minus 6x equals 0. Now I factor. I am going to take out the greatest common factor, which is 2x. All right, so I've got x minus 3 equals 0. All right, this 2x is also in its own little parenthesis because I'm multiplying it. So now I set them equal to 0. 2x equals 0. X minus 3 equals 0. And I solve them. Divide by 2, x equals 0. That's one answer. I add 3 to both sides. There's my second answer. I have 2 solutions. My biggest exponent is 2. Good. Good. All right. Let's take a look at the next problem. I'm going to set this equal to 0. I'm going to bring my x and my 2 over to the left. Why am I doing this? Because whatever x squared is, I like that to be positive. If I subtracted 3x squared from both sides, then my x squared would be negative. It would be negative 3. And then I have to factor out a negative 1 and go from there. So I always like to keep that positive. If you do it that way, it will just require more work. So I have 3x squared minus x minus 2 equals 0. To me, this says slip and slide all over. All right? If you do not know slip and slide, you need to go back to lesson 6 where we talk about it. Flip the 3 out back. I've got x squared minus x minus 6 equals 0. This should be a product sum. What multiplies to negative 6? That adds to negative 1. Well, it's minus 3 and positive 2. All right? I slip the 3 in the back of multiplication. So I bring the 3 back in through division. So I have x minus 1 because this reduces to 1. And I cannot reduce 2/3. So I bring my 3 up, and I have 3x plus 2 equals 0. All right? That is factored completely. These are things we've done before, factoring. Now the last step in solving is just to set each one of these equal to 0. X minus 1 equals 0. Therefore, x equals 1. All right. And if I have 3x plus 2 equals 0, I subtract 2 from both sides. I've got 3x equals negative 2. And then I divide by 3. So I have x is negative 2/3. And over here, I also have x equals 1. 2 answers. And my biggest exponent is 2. Perfect. On to the next one. Green. Here we go. That is already set equal to 0. That's nice. That's work we don't have to do. But I know I can factor out a greatest common factor. I can take out a 3 and at least 1x. And if I do that, that leaves me with x squared minus 1. Now, don't forget, factoring out by GCF is the same as dividing out our GCF, okay? So that's how I end up with x squared minus 1, by dividing it out. Now, I can take this, and I can set both of these equal to 0 and solve it, but you should be aware that even though I have 3x here, this is a DOX, a difference of perfect squares. If I factor that out, I should get x plus 1 times x minus 1. And please don't forget, anytime we take out a GCF, or a greatest common factor, that still just comes along for the ride. I cannot just leave that behind, okay? So now what do you notice that's different here than the previous two problems? I will show you my highlighter. Okay, for the first problem, I had 2 sets of parentheses, okay? For the next problem, I also had 2 sets of parentheses. Therefore, I got 2 answers, 1 and negative 3x, okay? For the first problem, since I had 2 parentheses, all right, I got 2 answers because I solved both parentheses. For this next one, I have 3 sets of parentheses. So ultimately, I'm going to get 3 answers, and that's fine. So if I T-bone this, which is what I call this, T-bone, 3x equals 0, therefore x equals 0. Okay, if x plus 1 equals 0, x has to be negative 1. If x minus 1 equals 0, x has to be a positive 1. So now I have 3 answers, and that's fine, because what is the biggest exponent I have in the problem? It's 3. So I should have 3 answers. Good to go. This next one. Right off the bat, I see that my biggest exponent is 4. I should have 4 answers when I'm all done with this, which means I should have 4 parentheses at the end right before I solve this. So I'm going to start by setting this one equal to 0. And this one's going to be a little bit more writing. Just bear with it. I'm going to start by subtracting 4x from both sides. So I have 2x to the 4th plus x cubed minus 8x squared minus 4x equals 0. Good deal. Can I take out a or greatest common factor? Yes, I can. I can take out an x. So the x, if I take 1x out, that means all of these x's are going to reduce by 1. So I've got 2x cubed plus x squared minus 8x minus 4 equals 0. So I cannot take out any more greatest common factors. What do I do, or how do I factor something that has 4 terms? I factor what's in the parentheses right here. I'm going to factor it by grouping. Okay, I'm going to group the first two, and I'm going to group the last two. And I'm going to factor those individually. So out of this first parenthesis right here, okay, let's do highlighters. Out of this first parenthesis right here, I'm going to take out a 2x. Oh no, I'm going to take out an x to the power of 2. And what's left? 2x plus 1. Okay. Now, I'm going to factor this parenthesis. All right. Now, I'm not going to take out a 4. I'm going to take out a negative 4. Because what's left, I want to be 2x plus 1. If I took out a positive 4, I would have a negative 2x minus 1 left. This does not match this. The whole purpose of factoring by grouping is that I want these two to match. So I'm not taking out a 4. I'm going to take out a negative 4. So those two parentheses in black match. Now, that is still what's in the blue parentheses. It equals 0. And I can't forget my x here. This comes along for the ride. Oh, great. Let me rewrite that. That's terrible. Sometimes this board gets uncalibrated. All right, so now, if you remember our factoring by grouping, okay, again, we'll bring this x along for the ride. Well, we factored out my x squared minus 4 goes in one parenthesis, and what goes in another parenthesis is my 2x plus 1. Okay? So, we can put our x in our full parentheses if we want. We have 3 parentheses, but we should have 4 answers. All right? So that tells me one of these parentheses I can factor again. This one I cannot. That's just an x. Comes for the ride. This right here is a DOS, a difference of perfect squares. That's x plus 2 times x minus 2. And this last one, I cannot factor anymore. So there you go. 4 parentheses to get 4 answers. And all I'm going to do is solve each one of those. Okay, x equals 0. Okay, that's solved. I didn't have to do anything. Nice. X plus 2 equals 0. So my x has to be negative 2. Right? X minus 2 equals 0. So my x should be positive 2. And this last one here, 2x plus 1 equals 0. I'll go ahead and solve this one. Minus 1 from both sides. So 2x equals negative 1. And then I just divide by 2. So this last x equals negative 1/2. 4 answers for a problem where the degree or biggest exponent was 4. Works perfect. The last problem. And before I even start that, you'll notice that was a lot of writing. Man, that was a lot of writing. But you know what? A couple of years ago, 6-point problem on the final exam was a factor by grouping. So you really need to be comfortable with factoring by grouping. Okay? That always pops up at one point on the final exam. Even if it's a multiple choice question, it pops up once, typically, but only once. So let's take a look at our last, man, thank God, our last one. All right, let's start, same deal, set it equal to 0. Plus 4, plus 4. So I've got x to the 4th minus 5x squared plus 4 equals 0. Okay? This is a factor sum factoring method. Factor sum. Okay? But keep in mind, I should get 4 answers. So I should have 4 sets of parentheses. So I'm going to say what multiplies the positive 4 but adds to negative 5? Negative 4 times negative 1. But instead of x is going here, my middle term is x squared. So I'm going to put x squared in both of these. If you don't follow that, that's in the factoring notes on how to handle that, okay? So I have 2 sets of parentheses, but I need 4. So guess what? Each one of these is a difference of perfect squares. Okay? This is x plus 2 times x minus 2. This one right here is x plus 1 times x minus 1. Boom! 4 sets of parentheses for a problem that has a degree of 4, where the biggest exponent is 4. So now I just got to solve each one of these. And this is where it's just easy. Okay? X plus 2 equals 0. So x is negative 2. X minus 2 equals 0. So x is positive 2. X plus 1 equals 0. So my x is negative 1. And if x minus 1 equals 0, my x should be a positive 1. 4 answers, okay, for a problem that has a degree of 4, or its biggest exponent was 4. Very good, very good. Factoring, if you get factoring, is not that bad to solve by factoring. You still need to get good at factoring in general. It doesn't go away. But this next method, solving by a quadratic equation, using the quadratic formula, isn't too bad either. It looks complicated. And again, you guys have done this in Algebra 1, maybe Math 8. I'm not sure, but I know definitely Algebra 1. So this should be somewhat of a review. So let's take a look at the first 2 problems and go from there. I'm going to start this out the same exact way. I always want to set this equal to 0. So I'm going to subtract 4 from both sides. So 2x squared minus x minus 4 equals 0. If you tried to factor this, you couldn't. You couldn't use slip and slide or the M method. It wouldn't work. There's no guess and check. You can't factor out a greatest common factor. None of it works. That's when we have to go with the quadratic formula. Now, I see the letters in this fraction here. I see an A, I see a B, and I see the letter C. So where do these come from? Well, the general or standard form of a quadratic is ax squared plus bx plus c. The coefficients for each term, those are the letters we're going to use. In other words, my a value is 2. My b value, don't forget, that's a 1 there. And we need to include the sign, -1. My c value is -4. Those three values, I'm simply going to plug in my letters for my quadratic formula and just solve it, and that's it. Okay? So I have negative b, okay, is negative 1. Plus or minus the square root of b, negative 1 squared, minus 4 times a, which is 2, times c, which is negative 4, all over 2 times a, which happens to be 2. So if I did this right, my a value, all right, my a value could go here next to the 4 and here with the 2. And it goes here next to the 4 and here with the 2. My b value should go out front here and I should negate it. And it's out front and I negate it. And I also square it here and I square it here. My c value, all right, there's one spot for it. It's right next to the a and the 4. Right next to the a and the 4. So you see where all these numbers go. And now I just do the math, literally. There's no more variables here. They're all numbers. There's nothing that's difficult anymore. Okay? So let's do this. If I negate a negative 1, it becomes a positive 1. Plus or minus the square root of. Now, this should not be difficult to do in your head. Even if it was, you have a calculator. I want you to just take what's underneath the radical and figure out that. Negative 1 squared minus 4 times 2 times negative 4. Okay? This turns into a positive 1. Okay? A minus 4 times 2 is minus 8. Times another negative 4 is plus 32. That gives me 33. That's what all this under the radical is. Square root of 33. All over 2 times 2, which is 4. That's your answer. That equals x. Now, we said earlier that every time you have a problem, the degree or biggest exponent is the number of answers you should have. We should have 2 answers here. And we actually do. That's how I have 2 answers. Let me explain. 1 plus radical 33 over 4, and 1 minus radical 33 over 4. This is 2 answers. You're going to take your 1 and your radical 33 and add them. And you're going to take your 1 and your radical 33 and subtract them. As mathematicians, we get lazy. Instead of writing it twice like this, we say, oh, we're just going to, it's the same thing as just plus and minus. That's our 2 answers. So there you go. If you want to try the next one, go ahead, because I'm about to do it right now. Let me get this out of the way, and let's get going. All right. Set it equal to 0. I'm going to subtract 3 from both sides. X squared plus 4x minus 3 equals 0. My a value is 1 right there. My b value is 4. And my c value is negative 3. Okay? It's the alphabets. A, B, C. There you go. Let's plug these back in. If you need to see the equation up top, you have it right here. I'll do that. I'll move this up here so we can see if we're plugging it in. The negation of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is 1. That looks good. So let's just simplify this. The first thing I should do is negate my 4. I get negative 4. Plus or minus the square root of, okay, this is 16. Negative 4 times negative 3 is positive 12. Okay? And if I multiply that times 1, it stays positive 12. This is 28. Good. Right? All over 2 times 1 is 2. All right? Now, that can be your answer, but if this is multiple choice, it would probably be in simplest form. I can reduce this radical. Oh, crayon is nice. I can reduce this radical right here. The one in here, I couldn't reduce. Okay? That was why we left it. But we're going to reduce this radical right here, and this should also be reviewed. If I take radical 28, that's like saying radical 4 times radical 7, because 4 times 7 is 28. And I know the square root of 4 is 2. The square root of 7 can't be reduced anymore. So this is what radical 28 will turn into. And I'm just going to rewrite it. So negative 4 plus or minus 2 radical 7 all over 2. You might be saying, oh, thank God, we're all done. But we are not. We have one more thing to do. If I have a common factor between all three numbers that are not in the radical, I can reduce them. Meaning, the number 2 goes into all three of these numbers. 2 goes into here once, 2 goes into here once, and 2 goes into negative 4 negative 2 times. So when I rewrite that, I end up with negative 2 plus or minus radical 7. I don't have to write the 1 in front of the radical 7 because anything times 1 is itself. Just like x, I don't have to write the 1 here because I know it's 1x. That's 1 radical 7. Anything over 1, I don't have to write as well. 5 over 1 is just 5, isn't it? So this is actually my solution. And there are 2. It's negative 2 plus radical 7, and it's negative 2 minus radical 7. This is a good way to write it, though. You don't have to split it up. I'm just showing you what it looks like to split up. All right, let's use the quadratic formula some more. If we had 16x squared minus 8, find all real values for which y equals negative 1. This is y. That's an equation. So if y equals negative 1, I'm just going to throw negative 1 in for y. Negative 1 equals 16x squared minus 8x. All right, well, I'm going to set it equal to 0. That's the first thing I got to do. Plus 1, plus 1. 0 equals 16x squared minus 8x plus 1. All right. Now, to me, that looks like that might be a perfect squares, not a dot. But that looks like it might be a perfect squares solution. But let me do that anyhow. Let's see what this ends up being if we use a quadratic formula. Now, the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's just rewrite that so we have that in front of us. Okay. My a is 16. My b is negative 8. And my c is positive 1. All right, let's do this. So, I have the negation of b is negative 8, plus or minus the square root of b, negative 8, squared minus 4, times a, which is 16, times c, which is 1, all over 2 times a, which is 16. Nice. Let's simplify. I have a positive 8 plus or minus the square root of negative 8 squared is 64 minus 4 times 16 is also 64 times 1. That's going to be 0. It's the square root of 0. All over 32. All right? The square root of 0 is 0. So I end up with 8 over 32, which reduces to 1/4. That's my answer. Interesting. Interesting. I like it. I like when things work out like that. But that raises the question, shouldn't I have 2 answers? I have 1 here. Technically, I do have 2. Let me explain to you. This is 8 plus 0, because the square root of 0 is 0, over 32, and 8 minus 0 over 32. They both end up being 8 over 32. So I technically do have 2 answers. They're both the same. All right. The next one. My A is 1. My B, I have no term with an x. Right here, I have negative 8x. I have no term that just has an x. So my B is 0. And my C is negative 5. All right, let's get going. The negation of B, which is 0, plus or minus the square root of B, which is 0, squared minus 4, times A, which is 1, times C, which is negative 5, all over 2 times A, which is 1. All right. So let's simplify. Negative 0 is just 0. That goes away. Plus or minus the square root of 0 squared is 0. Negative 4 times 1 is negative 4. Negative 4 times negative 5 is positive 20. I have 20 in here, all over 2. Oh, nice, we're done. No, we are not. What can we do? We can simplify this radical. Radical 20 is the same thing as radical 4 times radical 5. And the square root of 4? 2. Radical 5 cannot be simplified anymore. So instead of radical 20, I'm going to write it as 2 radical 5. Plus or minus 2 radical 5 over 2. And the beautiful thing that happens here, my answer is plus and minus radical 5. Not horrible. The more you do it, the quicker you get at it, the more you understand it, and the better you get at it. Okay. We're starting to feel somewhat comfortable with it. So let's just make things work for you by giving you a word problem. An application. Your school's jazz band is selling CDs as a fundraiser. The total profit, which we're going to call P, depends, okay, my total profit P depends on the amount X that your band charges for each CD. So X, we'll highlight these so we can differentiate them. X is what your band charges. Okay? P is the profit. All right? The equation P, which is your profit, equals negative x squared plus 48x minus 300. And x is what your band charges. Okay? Okay, that models the profit for your fundraiser. What is the least amount in dollars that you can charge for a CD to make a profit of 200. Right here, profit's 200. 200 is what P is. So in for this number right here, we're going to put 200. Okay? So 200 equals negative x squared plus 48x minus 300. All right. And now we can set this equal to 0. All right. I'm going to subtract 200 from both sides. Bang, I've got negative x squared plus 48x minus 500. Wow, that all equals 0. So I could do one of two things. I can factor this, or I could use the quadratic formula. I'm going to choose the quadratic formula because that's what we have been using. That's what I want you to use here. Instead of factoring, because I don't think this is going to factor, number one. Number two is when I use the quadratic formula, I only have to input numbers. Yes, there are large numbers like 48 and minus 500. But reason number three is I have a calculator to do some of that work for me. So let's do this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I just like to have that in front of me. That's why I rewrite. A is negative 1, b 48, c, wow, negative 500. Let's put all those values in for our A, B's, and our C. Let's do this. Let's not be scared. Negative B value, 48, plus or minus the square root of B, which is 48, squared minus 4 times A, which is negative 1, times C, which is negative 500. All over 2 times negative 1. Now, that's a lot of numbers that are big or bigger than what we're used to working with. I am going to put this right into my calculator, and I'm going to hit enter. And I'm going to do it once with a plus, and then do it a second time with a minus. In my calculator, I don't have a key that says plus minus. I have a plus and I have a minus, so I'll use them both individually. So let me open this calculator. Let me get out of what that is. And I'm going to hit alpha y equals and enter. That gives me my fraction. And I'm going to type this in exactly as I have it on the board. Minus, parenthesis, 48. And I'm going to start with my plus. The square root of, parenthesis, 48 squared minus 4. Then I have in parentheses negative 1. Then I have in parentheses negative 500. Wow. All over 2 times negative 1. That's a lot to type. So I hit enter. In my first answer, I'll bring that right here. That's one of them. That's when I have the plus in between. So instead of rewriting this whole thing, I'm going to go up here, and I'm just going to hit enter. That will put exactly what I have typed up. It saves me the work. Only thing I need to do is change my minus to a plus. Come on. I got to go here. In front of my square root, okay? In front of my square root, it used to be a plus. I'm going to change this here. Yeah. Oh, I can't write on it. This plus is going to turn to a minus. I go here, it was a plus, bang, now it's a minus. That's all I have to do. Enter. That's my second answer. So, there are actually two amounts that I can charge to make a profit of $200. Now, this is money. It should go 2 decimal places. So I can charge $15.28, or I could charge $32.72. All right? What is the least amount? This is smaller, so that's my answer. Whew, I like that calculator. Use it when you need it. We are getting close to being done. This video is slightly longer because I've had more time to work on it straight, and I'd rather have one video instead of 2 or 3 like the other lessons. So let's do the last word problem, and then I'm going to show you a little trick on the calculator that's going to help us immensely. Okay? Number 2. Projectile motion in feet is modeled by the equation h equals negative 16 t squared plus v sub o times t plus h sub o. These are weird things we haven't seen. But let's just read the rest of the problem. Where h represents the height of the projectile, t represents the time. All right? V sub o represents the initial velocity. Hopefully they give us that. That'd be nice. And last but not least, h sub o, which is right here, represents the initial height. Let's hope they give us those things. That would make life easy. A football player standing atop a school building that is 75 feet tall throws a football straight upwards with an initial velocity of 64 feet per second. What is the maximum height of the football, and how long was a football in the air? Oh boy. Okay, so here we go. Ready? The initial velocity, which is nice, is 64 feet per second. So my v sub o is 64. All right? But I don't see an initial height. But they do tell me that this football player is standing atop of a school building that's 75 feet tall before he even throws it up. So my initial height is 75. Okay? So let's plug those two numbers in. And we have h equals negative 16t squared plus my v sub 0, 64t, plus my h sub 0, 75. All right? And they want to know 2 things. What's the maximum height of the football? Okay, and the second thing is, how long was the football in the air? All right, so 2 of these things they're asking us. One is review from quadratics that we've done before. Finding the maximum height. All right? Finding the maximum height. Let's start back in green. To find the maximum height, I need to find the vertex. Okay? This parabola is opening downward. How do I know that? My a value is negative. That means the vertex is actually the maximum. So I need to find the time and the height, the x and the y value of that vertex. I can find the x value, which in our case is t, not x. That's negative b over 2a. Let's write a little note here. My a is negative 16. My b is 64. And my c is 75. The same values that I plugged into my quadratic formula are the same ones I've used before to find my max. All right? So the negation of b, which is negative 16, all over, yeah, I'll be okay. The negation of b, which is 64, all over 2 times a, which is negative 16. That's negative 64 over negative 32. That's 2. At a time of 2 seconds, that's when the ball is going to reach its max height. How do I find height at time 2? I simply take my heights and put 2 in per t. Negative 16 times 2 squared plus 64 times 2 plus 75. All right. My goodness. This is a big problem. We have 4. That's 2 squared. Times negative 16, that would be negative 64. Plus 2 times 64 is 128. Plus 75. All right. These two would give me a positive 64 plus my 75. And you can do this in the calculator. You can put that right in the calculator, but I'm using mental math. It keeps me sharp. All right, that should equal 139 feet. So this is the max height, 139 feet at a time of 2 seconds. That's when it happens. That seems like a lot, and we are only halfway done with the problem. Wait till I show you how the calculator would have helped us. Yeah, it would have been nice to use a calculator on this problem. Let's do the second part. They want to know when the football, how long it was in the air. The football stops being in the air once it hits the ground, which means the height would have to be 0. So I'm going to take height 0 is negative 16t squared plus 64t plus 75. And I'm going to put this in the quadratic formula. And then, because those are big numbers, I'm going to use our calculator to do it for us. Okay? So it's the negation of b, 64, plus or minus the square root of b, which is 64 squared, minus 4 times a, which is negative 16, times c, which is 75. Oh, man. All over 2 times a, which is negative 16. Yeah, that's a lot. Put that in the calculator because that's a lot. Okay, turn this on. Come on, calculator. I need you. I'm going to put in our fraction and type it in exactly as that. The negation of 64 plus, I will start with my plus, the square root of 64 squared minus 4 times negative 16, yeah, times 75, holy smokes, all over 2 times negative 16. That's a lot. So I'm going to take that, put that right here, because we're going to have 2 answers. Our next answer is going to be the same thing, except we're going to have a minus sign in front of the square root. I go here, here, up. Here, here. Let's go all the way over. Come on. Let's make that plus sign into a minus sign. Bang. And enter. So we have 2 answers. So how do I know which answer is the correct answer? Here's a little hint. Time can never be negative. Boom. How long is the football in the air? 4.95 seconds. Or we could say approximately 5 seconds. That was a major problem. If you could have done that, you are sitting in a good position right now. All right? But once I tell you how to use a calculator to get solutions like this, you'll be much better off and more comfortable. Obviously, sometimes in a test, they ask you to do things algebraically, and you need to know how to do them. Okay? In my experience, if this was an algebraic problem, they probably would have asked you to either solve for the max height, solve for this, Or they would have asked you to solve how long the football is in the air, this. They probably wouldn't have asked you for both. If they would have, it would have been the last 6-point question. That was very long. Here's where everything comes together nicely. Okay? If I want to solve a quadratic equation by graphing on the calculator, okay? I hope, first of all, you know that anytime you ask for solutions for a quadratic, that's the same thing as asking for the zeros, which is the same thing as asking for the roots. And in the calculator, the solutions, the roots of the zeros, they're the x-intercepts. They are the points where your graph touches the x-axis. You'll see here, this happens to be at 3 and 6. Because here's 5. So my solutions for this particular problem will be x would equal 3 and x would equal 6. Okay? So the question is, how do I do this? Better yet, how do I do this and have the calculator tell me where it crosses? Because a lot of times it doesn't cross nice here at 3 and 6. Maybe it's in between the numbers 2 and 3, and you have no idea what decimal that might be. The calculator can tell you. So, let's take a look at what we have here. I have the quadratic equation right here. Again, nothing's going to change. I'm going to set it equal to 0. I'm going to subtract 15 from both sides. I'm not dividing by 15. I just underline that. And this is what I have right here. That's what I need to put into y1. Okay, these are nice the way these are typed out with 50. So I'm going to go to y equals. I'm going to clear this. And I'm going to put 2x squared plus 7x minus 15. I'm going to put that into y equals, okay? Now the next thing I'm going to do is I'm going to take a look at the graph. Wow, crazy. In fact, I'm going to change my window. I'm going to zoom. I'm going to go to standard window because mine was not set to standard. Standard, once I hit zoom and go to 6, gives me a 10 by 10 window. There it is, up and down. I can't see the vertex here, but I don't need to see the vertex. I only need to see where it crosses the x-axis. Now, in order for the calculator to give us these answers, all right, I'm going to use something that's called the zero function. Because so remember, zero, the x-intercept is the same thing as a 0, right? So I'm going to ask the calculator to find my zeros for my x-intercepts. So above trace, in blue, okay, I hit seconds and trace because I want the calculator to calculate place 2 or 0. All right, let's try one on the left. Okay, I'm moving left until I see my little spider dude. Keep on coming. All right, unfortunately, I'm going to stop this now. I know, right? Cliffhanger. And I will continue this later, and we'll do these calculator problems.